ice water. It is amazing how much of a difference that makes. I was doing one of these trainings last week. I don't know if you can see that red mark on my hand right there, but there was a lady who was soldering, and I was kneeling, and I put my hands on the table like this to stand up, and she happened to move the iron right under my hand, just like that. And I didn't react to it instantly because my weight, was on my hand, right? So that should have been an enormously bad burn. But I instantly got it into a bowl of water, and it makes a huge, huge, huge difference. People don't realize that skin doesn't burn instantly. I mean, it starts to burn instantly, but it then continues to burn down through the layers over a period of time. It can actually be still burning minutes after you hit the original heat and then pull it away. So if you get it into ice right away and start cooling it down, it's huge. And that's everything bad that can happen today. From here, it's all ahead. Okay? It's all going to be good. It's all going to be wonderful. So we want to move an iron over onto that side. Actually, so Hansel, where should I put the projector then for the presentation? Should I put it here? Yeah. Okay, then just move that over there. I will slide this over here. Where's the cable to plug this in? Okay, so my name is James Newton. Are we at a point where we should get started, or are there maybe more people coming?
I think we can get started.
Right.
Yeah.
So for anybody who hasn't already met me, I am a person who is incapable of finding the HDMI port on. There's no HDMI port on this thing.
Get shifted.
Good, it wasn't me. So I've been doing weird stuff with electronics for 30 years. That soldering iron right there was purchased by my father for me when I was a young man back in 74. I was a teenager. 73, 74, somewhere around there. It's actually made by a company from England, but they opened up a factory in Stirling, Illinois. It does. And had to replace the tip on it, but other than that, it's been running fine since then. So it's been a fun thing. And yes, I've burned myself a number of times with that iron. My favorite one, other than this one that I did last week, was when I was first learning to solder, and I got the cord caught on something, and it pulled the iron out of my hand, and I immediately caught it. Right? Because that's your natural inclination, is to catch anything that's falling. And can you guess what part of the iron I caught? Yes, of course you can. And I didn't have water handy or anything like that, so I burned myself quite nicely. And so where's that other bowl of water?
Oh, it's in the
Four. Can we bring that one out? Thank you. It's okay, as long as there's a little bit in there. It's going to melt some more, and by the time we actually get to soldering, because we're going to do a little presentation here, just to make sure. So it looks like that's on. And so what do I do to make this actually project? Do I push the power button now that it's orange? Okay. And it goes to green. Look at that. We have the technology. So a very nice gentleman by the name of Travis Good, who is a very good person. He bought these red irons on the stands so that we could teach people how to do soldering for the Maker Faire, which is coming in October of this year.
We're bringing it back.
Yep, we are going to fill Balboa Park.
Oh, in Balboa Park.
Yeah, in cooperation with the park, everyone, well, not everyone, almost every one of the museums is going to have makers tucked away, and there'll be some spectaculars outside. And it's going to be quite the show. So our thanks to Travis for purchasing those. We're not doing two-finger scrolling. Do this one. And Hansel, do I just drag this over there and then put the next one else? Or how about if I drag it this way? There we go. Okay. So this is the presentation that was linked from the meetup group. How many people actually went through the presentation? Nobody? One? Okay.
I didn't see this slide though. There was a 101, not a 201.
You know, you're right. I think I did link to the 101. It's 99.9% the same. I just recently went through it and did some revisions on this, so I'm going to use it instead. Okay, so there's a link there. If you need to contact me about anything, that's my email address. So I'm more than happy to talk to people about education and about the Maker Faire and all that kind of good stuff. Okay. So soldering is not welding. The difference between soldering and welding is that in soldering you melt the solder that goes around the components that are being held, whereas in welding you actually melt the actual components that you're welding. Okay, so this is kind of a schematic diagram. This is the soldering iron that comes in here and touches the pad on the printed circuit board, as well as the lead. So you want to touch with the tip of the iron both of the things that you want to get hot, and then we feed in the solder, the little silver wire that melts, and then that forms a glob and flows down into the joint between the two and holds it all together. Okay. So the reason why the solder is meltable at a lower temperature is because it's a combination. It's an alloy of the two metals, and for some strange reason, when you mix the two metals together, they melt at a lower temperature. Any chemists in the group? No? Okay. There's a reason for that. I'm not going to get into it today. So soldering iron tips are hot. Please do not touch them. Just in case anybody's confused, that's the hot part. That's not. I apologize for explaining that, but I did at one training have someone who didn't understand that. So it's important. I've already talked to you about the little water bowls. That's an important thing. In rare cases, solder can be splattered, so we want to be a little bit careful about that. It's 99.999% of the time not an issue, okay? I've never had a problem with it, so I'm not going to worry about that too awful much. What I'd like you to do now is go ahead and plug in or turn on the soldering iron that you're working with. So we need to get them heated up. Be mindful of who else needs to plug in and how, oh, something happened. Then something happened. Oh, that turned off the projector. So we need that, yeah, there we go. Okay, good. That'll come back on and then I won't be lost. Okay, so all of those should start heating up.
Oh, that's cool.
Yeah, no worries. Give it a minute. Okay, so nobody's using this one or this
Well,
one?
yeah, I need one. I'll use one.
Oh, this one here? Okay. Over two. So the other thing that we want to do is, while we're kind of waiting on the irons to heat up, is we want to get a little bit of water onto the sponge. There's many ways of doing this. One of them is just take a little piece of ice, if there's any left, and stick it on top of the sponge and let it melt. Well, that'll work. Flashing this lamp button. So
Yeah, I think, yeah, it's cooling.
Cancel? Oh, he's working with something there. Okay. We won't worry about it. The pretty pictures aren't all that important at this point. So, some of you probably have heard or understood that solder, that lead was banned from solder some time ago. The reason for that was because people throw electronics away into landfills. had absolutely nothing to do with worker safety or health risk to the people who are soldering. It has to do with the health risk to the rest of the planet after people solder things with lead solder and then throw them away in landfills. Okay, that was the issue. So number one is don't eat the solder. Don't put your hands in your mouth or nose until you wash your hands after soldering. Especially don't chew your nails, okay? If you're a nail chewer, please try to suppress that while we're doing this, consciously or unconsciously. Don't do that. And then the other thing is that you want to make sure that you wash your hands real good. If you typically chew your nails, be sure and wash your hands really good and get everything out from under your nails because it's a natural place that just stuff accumulates, okay? So we're going to try not to breathe the fumes. We've opened some windows and the ventilation and doors and the fans are running, so we should have enough ventilation in here to not have a problem. The reason why you don't want to breathe the fumes actually has nothing to do with the lead. It actually has to do with the rosin, which is inside the little stick of lead. There's a little bit of stuff called rosin, which is there to make the solder flow a little bit better. And as that burns, it can release some vapors that are mildly irritating, harmful. Rosin, believe it or not, is actually made out of pine pitch. So you can just need to go to your local pine tree and get some pitch and use it for your soldering. And I have actually tried that, and it actually kind of works. Rosin is actually purified pine pitch, so they put it through some kind of a process that makes it hard. It's exactly the same stuff, believe it or not, that is used to rosin a violin bow. And when I found that out, and my son who plays the violin and was always losing this $20 little thing of rosin, I found an online company from Arkansas or Missouri or someplace that goes out and collects pine tree sap and processes it into these lumps that are about so big and then sells it online. And so I bought a bag this big of these rosin lumps for $5. Every time he loses it, he just go ahead and have another one, and we're good. He hasn't lost the violin yet, so we're doing well. Okay, so this is the most critical slide in the whole thing. This is the one part that's actually important that everybody really needs to learn. Well, other than the safety stuff. This is the thing that typically goes wrong with soldering. It's all about time. Okay, so what happens when you touch the tip of the iron to some kind of metal is the heat begins to flow from the iron tip into the metal. And the rate at which that heat progresses into the metal is kind of a fixed thing, right? It doesn't get there instantly. It takes a little while for the heat to go through. So what you want to do is you need to get that metal that you're touching with the iron hot enough at that point that the solder will melt around it, but you don't want the metal to get hot all the way up to the point where it goes into the component, right? Because then the component's going to melt or the board's going to burn or whatever. So the way that you do that, the way that's been proven to work the best is you want your soldering iron to be very, 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 very hot, okay, as hot as you can get it. You touch it to the metal, immediately get the solder on there, grind it around a little bit to make sure that you're making good contact and that the solder flows all around the areas where it needs to be. And you get the solder off, and then you take the iron off. And so the time period between when you put the iron on and when you take the iron off, you want that to be as short as possible, okay? And what happens then is that the metal gets really, really hot right away, and the heat starts conducting down the metal into the component, right? But now you're done soldering, you let it go, and it cools back down again before it has a chance to hurt anything. A lot of people are of the opinion, or some people make the mistake of thinking that you should have your soldering iron just hot enough to melt the solder, okay? And what happens then is that when you touch the soldering iron to the metal and the heat starts to flow, it's slowly bringing the heat up, slowly bringing the heat up to the point that the solder melts, but at the same time that heat's flowing through the metal into the component and burning it, okay? So you want hot as all get out, get on there, get the solder on there, get the solder off, and get the iron off, okay? So this is the dance that we do. So there's this thing called muscle memory, so I apologize for asking you to look dumb, but you actually have to make the motions, okay? Because you actually learn then what the motions are and you do them automatically. So here's the dance, okay? Everybody do this with me. Take the iron, and you put it on, and you put the solder on, then you take the solder off, then you take the iron off. Okay, so that's the sequence. Soldering iron, solder, solder off, iron off. Okay, so that's the way you're going to do it. Now, when we do the solder on, and then we put the soldering iron on, then we put the solder on, we may stay there for a little bit, just like a few seconds, like, count of 1, 2, 3, and then no matter what happens, even if the solder is not flowing, even if it's not working, even if everything's all messed up, get off anyway. And then wait for a little bit for it to cool down and do another cycle. Okay? So whatever you do, don't hold the solder on the component continuously, just very briefly. Okay? Alrighty. So the solder is going to flow to the heat. So when the solder melts, what you'll see is that that molten metal will flow to wherever it's hot. All right. So what you want is you want both the component lead and the pad to both be touched by the iron so that they're the hottest things. And then the solder is going to come in on the other side. And as soon as those two things are hot enough, the solder will melt and flow over to the iron. And you'll actually see this while you're soldering. Okay. So the solder always is going to flow to the heat. Oh, no, don't do that. There we go. So the first thing we have to worry about is tip care. So in order for the heat to transfer from the soldering iron tip into the metal, the tip has to be clean. It has to be shiny. So it has to look not like that, which is dull, but like that, which you see how it has these shiny parts to it. I mean, the whole thing doesn't have to be shiny, so there's burnt and gray parts all over here, that's fine. But this part down here is nice and shiny, and that's what we want to see, okay? And you want, whatever part of it is shiny, that's the part that you want touching the metal that you're soldering. Okay, so the first thing is go ahead and take a look at your tip, see whether or not it looks shiny. If it doesn't look shiny, try wiping it on the sponge. Now, you have to wipe very quickly. Don't, oh yeah, I'm sorry, by the way, these stands are not very good, and the iron tends to get stuck in them. So you kind of have to hold the stand down sometimes in order to get it out. Okay? Now, don't be afraid to hold that iron good and hard in your hand. That red part probably shouldn't have been red. It should have been, blue or something. It's going to be cool, so don't worry about that. And then just kind of wipe it on the wet part of your sponge very quickly. Don't hold it on the sponge because obviously it'll burn the sponge. Now, if you find that it's staying gray and it's not cleaning up, there's a couple of different things that we can do. This thing is called tip tinner. It is a wonderful little thing. I'm going to take you because it looks like that one's a little bit burnt. What we're going to do is just hold this like this, and if you can look up for just a second, I don't want to distract anybody and get them burned, but what we're going to do is take the tip, push it down into that, and kind of grind it in there. And you see how it's melting and fuming a little bit, and you'll see that the tip comes out really nice and shiny when you do that, okay? If it doesn't, a couple more times grinding through the hard part, sorry, will help. Anybody's tip need tinning, or do they all look shiny?
What's it called again?
Tip tinner.
Tip.
Yeah. So in that presentation, you'll find a link to the preferred product and all kinds of good information about it. Okay. I'm going to pass this around. If anybody's tip does not look shiny, please go ahead and use that. If anybody's tip looks really, really bad, then let's see if I can steal this actually. Should come out of there. There we go. This is a wool. Now, if you buy this from SparkFun, I think it's $15 or $20 or something like that. You can go down to your local grocery store and find exactly the same thing. You want the one that's the copper kind of or brass color, not steel wool, but the kind of brass one. So this is a last resort. Okay, try not to use that. Use the other thing that'll work. That'll work better. So what this is doing is it's mechanically. You're scraping off the burnt stuff off the tip of the iron. Okay? Okay, does anybody's tip still look garbagey, or they all look a little bit shiny at least? That one's being a pain? No, it's okay. Think it's okay? Okay, if you need to, go ahead and scrape it a little bit on that. Oh yeah, we did. Okay. So again, keep in mind, while we're doing the soldering, you may find that your tip becomes gray and nasty looking again. Just over time, they oxidize. So, go back and clean it if you find that you're having problems, okay? So just a real quick thing, it's important that the components that you're soldering, oh my goodness, they don't have components. The components that you're soldering need to be clean, okay? And sometimes what happens is in storage, you'll find that electronic components build up a coating on them that causes problems. And you want to just rub that with like a paper towel, maybe use some isopropyl alcohol if you have it, and that will help a lot to take care of the problem. Okay, so in case anybody hasn't figured this out yet, this is the little thing that I'm wearing, which is what you're going to make. It's called a maker badge, or a maker soldering badge, I guess. There's another thing that's a maker badge as well. I'm sorting through this because I have a few of them that are, shall we say, refurbished. And I don't want to use those if we don't have to. Looks good. Everybody got one? Oh, you did. I gave you one 3 times. I know. Okay, great. So the first thing to do, go ahead and open this up and take out the little board and lose all the parts. Okay. I'm gonna picture on this slide probably isn't the best thing in the world, but I'm gonna talk a little bit about component orientation. Obviously, when you're working with electronics, sometimes there are components that should only go in one way. And if you put them in the other way and solder them in, then when you apply power, it lets the magic smoke out, which, as we all know, is what causes electronic components to work. Without the magic smoke inside the components, it will fail to work. Okay, so some of the components that you have in your little kit are these little LEDs, the little white things. What I'd like you to notice is that one of the leads is longer than the other. So you've got a long lead and a short lead, okay? The general rule in electronics is that the long lead goes in the square pad. So if you look up here at the top of your little robot board, up here where the 2 eyes are, and you look at the little pads where those leads are going to go in, you'll see that one of them is square and the other one is round. Obviously both of the holes are round, but the pad around the hole, one of them is square and one of them is round. And you can't really see that on this board terribly well, but it's the same sort of thing for several different components. So here's an LED, square pad with a long lead. This is a nice big capacitor. We're going into a square pad here, round pad there, medium size. And also other components that have multiple pins, like this network resistor, for example, you'll notice that there's a dot on one end of the component. Okay, that indicates that this is pin number 1. Again, it goes into the square pad. So pin 1 always goes into the square pad. There's a voltage regulator here, same thing. One of the pads is square and it goes in. Now, this guy right here, this potentiometer, doesn't matter which way it goes in. Resistors typically don't have a polarity, so it doesn't matter which way you put them in there. All of the pads are round, so you're good. Okay.
Quick question on the capacitor, that's an electrolytic.
Yes.
So a non-electrolytic doesn't matter.
It doesn't matter. Right. Exactly. I probably should have put one of those on there, but basically, anytime that you have one lead longer than the other, or you have a dot next to one of the leads, it matters. And look for the square hole. Okay. Now, don't put your LEDs in yet. I mean, it's fine if you did, but go ahead and take them back out again. I just want to get that in your head for now, and then we'll come back to it here in a little bit. Okay. All right. So let's just do a little bit of a review. Okay. The tip is clean, shiny, and tinned with molten solder or with the other side. The pads and the part leads are clean. The part is correctly positioned. You know which one is pin 1, which one is 0. You got a hot soldering iron in one hand. You got your solder in the other. Oh, does everybody have a little piece of solder? If anybody doesn't, let me know. Okay, and then what you do is you go 1, you touch the tip to the components. 2, you touch the solder to that point, not to the iron, but to the component itself. Wait for it to melt. Then check that it's flowing everywhere it needs to. Take the solder away, then take the iron away. Okay, and don't stay on there for more than 3-4 seconds. Okay. The first thing that we're going to do is actually really easy. instructor badge. We're going to try and do this together so that people have questions, they don't get too confused. There is, on the back of the robot, there's this big silver pad right here in the middle, and that's where the battery is going to press. We want to make sure that there's a little bit of a mound on that pad so that the end of the battery isn't pushing against the whole pad. It has one point to push against in the middle. So what I want you to do is go ahead and set that down with the back side of the robot up, right? So you can get to that pad. Take your soldering iron in one hand, put it right in the middle of that big pad, push down hard with the iron to make contact, okay? And then add your solder with your other hand. Make sure you have your solder in your other hand first. Oh, you didn't use solder. Okay. Was there a little thing of it, or no? Okay, let me grab something out here. And then,
Here.
oh, you got it. Okay. Good. And then kind of feed in some solder. Take the solder away. Take the iron away. And I'm going to run around and look over everybody's back, and I'm going to hope that somebody messes it up, because that's how we learn. Not by shaming, but by good examples. Okay? Go ahead and try. Anybody? Big lump. That's good. That's a good start. So keep going. How you doing? All right? You're doing a lovely job there, but do more. Don't be tentative with the iron. Push the iron onto the metal pad as hard as you can. Okay? Go ahead and make it as big as you can. Cover that whole area. Yeah, we want to cover that whole metal pad.
You want to cover the whole metal pad?
Yeah, I mean, you don't have to cover the whole metal pad, but cover the whole metal pad. That is absolutely perfect, which is useless to us. We want people to make mistakes, so then we can show everything.
Give me a surface mount for
Yes.
it. Screw it up. For you.
That's good. That's good. Yeah, surface mount part is great. No, really, it's really important that people make mistakes because that's how you learn. Yeah, this is a beautiful mistake. Hold on a second. I want to show everybody this, if you don't mind. So, can anybody tell me what went wrong with this?
Took the iron off
Took
first.
the iron off first. Thank you very much for doing that. I very much appreciate it because it gave me the opportunity to teach. Okay? So, now how do you fix that? You just put the iron back on it for a second, melt it, and then pull the solder away. Good. That looks absolutely excellent. This is good. So one of the things you can do is, because it's kind of lumpy, you can kind of rub the iron around in it. That's a fun way to do it. So you know what I might do is, the part that's shiniest is the shoe, because that doesn't have a round tip.
Right.
So just make sure that you're pushing. I think you were already. Okay. And if you have to push the solder into the iron a little bit, go ahead and do it. That's some good cheating. Wow, that's really, okay, that's more than long enough. Don't stay on too long. That was a brilliant mistake. Thank you for doing that so I can share. Don't stay on more than 5 or 6 seconds, okay? Oh, yeah, see, we're not clear. Yeah. Weird. Now, see there how it's shiny?
Right.
Okay. Now what you can do too is you can just touch the tip with the solder. And you see how you get a little ball of solder on there?
Oh.
Now try it and you'll find that it's going to work like instantaneously. Careful, don't burn me.
On this, if I put it on the way high,
Slopes?
yeah.
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 That's a real high end unit, so that's okay to turn
Now,
it down a little bit.
is the very, very tip slightly cooler than the actual side of the
No, but that's a brilliant observation. Well, no, actually, yes, and that's a brilliant observation. So what happens is, as you get down to the tip, a little bit of it's hard, the amount of heat that's leaving the metal, right, is not being replaced as fast because it has to conduct down to the very tip. But the other thing that you're probably noticing is that if you just use the tip of the iron and that's the only part that's touching, you don't have very much surface area contacting between the two surfaces, right? So you don't get that big heat flow that you need in order to get the part warm. So you definitely want to, like especially when you're soldering a lead that's coming up through a board, you want to kind of come along and hit along the side. And the other thing too is sometimes you'll find it, so like here's the surface of the printed circuit board, right? And you come in like this with the soldering iron, that's not good. If you come in like this with the soldering iron, now you get a lot more surface area onto the pad and you get that heat. And so what you'll do is you'll find an angle where if you go too far this way, then the pad's getting hot, the lead isn't. And if you you go too far this way, then the lead's getting hot, the pad isn't, right? So you want an angle that's kind of somewhere in the middle, and as you get experience, still do it. Okay, has everybody got a lump of solder on their board? Okay, let's move on to the first component. Here we go. This is the little battery holder. So if you look in your little bag of parts, it's this weird little bent up piece of metal. Okay. This one is an interesting thing because it does have an orientation, but it doesn't have a square pad. So remember all those rules I told you about how there's always a square pad? That's a complete lie. So this is a component that doesn't have a square pad. So how do you know which way to put it in? Well, if you look at the white part of the little printed circuit board, that's called a silk screen because it's actually applied by a silk screen in the manufacturing process. And you'll notice that there's a notch at the top of the silk screen. That notch matches the little notch at the top of the metal thing.
So they changed the design from the picture.
Exactly. Oh, did they?
Yes, right, it's upside down. Ours is upside down, and theirs is upside down.
You know what? That's completely stupid. You want that notch at the bottom
Exactly.
because then the battery won't fall out.
Right.
So never mind what the silk screen says. We know better.
But
There's a printed circuit board designer somewhere that just rolled over in his grave because I said that. But
it might change the polarity on the.
no, it's fine. It's fine.
Hello?
So what you want to do is just go ahead and get that through there. Now what you'll find is that you're going to be soldering on the front side, but the component's on the rear side. Okay, so you're going to put the component on the back, just like I have it here. Okay, and then you're going to turn the whole thing over and set it down. And as soon as you do that, the little holder's going to fall out, and it's very, very annoying, right? And you're going to keep trying to get it on there so that you can actually solder it. So one thing that you can do is put it through while you're holding it with your fingers. If you have really strong fingernails, you can nick the little leads on either side to push them out, and that will then cause it to stay on there without falling out. Did that make any sense at all? Okay. If it didn't make sense, let me know, and I'll be happy to explain it some more. But this is the way that we want it, with the battery holder on the back side. Okay. So in other words, the battery holder is over that pad that we just put all the solder on. And then you want to lay it down, and then you want to lay it down on the table the other way, so that the face of the robot is up, because you're going to solder the two little places where the lid comes through the pad.
The battery's just gonna wedge into this.
Exactly right. Yes.
So the big pad is the positive, I take it, or the ground?
The big pad on the board is the positive, and the holder is the negative. Yes. Okay, so once you have that kind of ready to go ahead and try soldering one of the leads. I'm just going to check really quick and make sure that everybody's got that the right way around. Because if you get the wrong way around, it's hard to compensate.
That's where I've left this.
Everybody looks
Oh,
good.
yeah, great.
No, that's backwards. Put it on the other side. There you go. Awesome. And you should be fine. You're following a silk screen, which is actually probably okay, but if you put that notch on the bottom instead, it might help the battery not fall out. Okay, now once everybody's got it in there, go ahead and solder. Now this is another little rule. This is a little tip, okay? It's a little extra that's not even in the thing. Always solder one side first. Oh wait, I almost forgot one of the really important safety things. When you're soldering this, do not try to hold it in with your finger while you're soldering it. I apologize again if that sounds like I'm being dumb. I personally have done that many, many times. Okay, so don't do that. Next thing, what was I was about to say something and then I interrupted myself. Oh, I'm good at that. Oh yes, solder one side, lift it up, make sure it all looks right, and then go back and solder the other lead. Okay. The reason for doing that is because you get the one lead soldered, now it's in there, it's not falling out. You can take a look at it, make sure that it's correctly positioned, and then do the other lead. Okay. How are we doing? Everybody got both leads soldered? Now, one of the things you want to do is make sure that the solder has flowed evenly around all sides and through. See what we did? Well, that looks lovely. Looks very nice. Looks quite good. Okay, would somebody please make a mistake so I can show what was wrong? Okay. Let me see, do we?
Cold.
No, it's just got a little bit of smoke. I was really hoping it was going to be a cold solder joint, but nope, it's good. It's great. Okay, so there's this term called a cold solder joint, and just to be clear, that does not mean that it's in any way cold. I mean, they're soldered and all heck, but what happens is that sometimes the solder does not flow around both things. Like it'll get on the pin, and it'll look like it flowed onto the pad, but when you look really, really close, you'll see that it didn't flow onto the pad. Okay, and that's one of the things that causes problems in soldering. As a matter of fact, that's important enough that I want to hop forward just a little bit. If I can direct your attention just really quick to this one. This is a picture of a cold solder joint. It's really, really obvious. So you can see what happens is that the solder got onto the pin here, but didn't get into the pad. This is another example here where the solder got onto the pad and the pin, but only on one side. You can see that there's nothing behind it, so you want to make sure it flows all the way around. This one is really interesting because when you look at that, it really looks like there's solder on the pin and there's solder on the pad. There is no electrical connection between that pad and that pin. And I know because that's from one of my boards that was sent back by a customer who could not get it to work and had examined everything and had soldered just exactly the way I taught him to, and somehow or other managed to get a cold solder joint that I could not identify until I was in there with a meter looking at it. So you want to make sure that you get everything to really flow around. Okay? All right. We are moving on. Is anybody still soldering the battery thing? I don't want to rush people, so let me know if you need a little bit more time. Don't go ahead, because there's important things that we learn at each step along the way. Okay. Let me just check with these guys real quick to make sure that they're all right. Okay, you guys good? That looks lovely. Awesome. Okay, great. So moving on. The next thing that we're going to do is the tie tack. Okay, now they've changed the design ever so slightly, but this is the little nail, the little teeny tiny brass tack that's in there. And what we're going to do with that is it goes on from the front of the robot through to the back. Okay, so there's the front of the robot. You're putting the nail through his forehead as opposed to through his nose. I don't know why they changed that because I think it made a great nose. So that it's going to stick out the back. And just so that you understand what's going to happen there, this is the little backer part to the tie tack, right? So when it's done, like this one is, then you're going to stick that tie tack through your clothes and put the little thing on the back, right? So you want that to be from the front to the back, and then turn it over again and solder it on the back, okay? And just, again, do a nice job of getting lots of solder on both of them. Make sure you get a real good connection, and move on. And keep in mind that the bottom of the thing is getting hot. We may actually get to the point of burning some of Hansel's lovely tables here. Sorry about that. You know, I was thinking I should have brought down cardboard, and I didn't. So, if anybody manages to hurt anything, did you do it the wrong way around?
No, it actually melted the plastic, stuck to the plastic.
Oh wow, that was.
It didn't cool off fast enough.
Didn't cool off fast enough. Okay, so, oh, this is beautiful. This is actually good. Okay, so this gives me an opportunity to show you my favorite problem that happens and how to fix it. Let me back up one slide here because this is just so cool. Oops, no, not on that. This one. I'm going to back up one slide. So this is what happens when you get a blob of solder on something. What's happening here is that the blob of solder is preventing the component from going through. Okay? So the way that we fix that, I'm going to steal your iron for just 1 second, is that we take the soldering iron and we put it up here like this on the bottom of the part that we want to clear. Actually, I'm going to do it this way. So we do it on the bottom, and we hold it, and we melt it, and then we go like that. Okay? And what happens is that the solder flies off and hits the table. And if you look right here, you see it's made a lovely little piece of artwork on Hansel's nice table, which we will remove by just scraping it. No mark, really, I swear. So that's a dangerous piece of lead, which we will get rid of later. Okay? Yeah, you can. This is yours. Okay. So that's the whack method of getting solder out of a hole or removing solder from something. Now, most soldering instruction will tell you that desoldering tools or solder braid or wick is the correct way to do never use those because they tend to damage the printed circuit board. It's really easy to mess up a PCB when you're using the desoldering tools or the braid or the wick. However, if you're going to go out and get a job doing this sort of thing, and they ask you how to desolder stuff, you say, well, you should always use a proper desoldering tool or wick in order to desolder it. Don't tell them that you whack things on it.
Just smack it really hard.
Right, you just
fix
hit
it every time.
Exactly how it works, right? It is.
It is.
So, anyway, just so you know. Okay, so everybody got the type pin in? Are we ready to move on to the next step? Not there, not there. Okay, so now we're going to do the LEDs. This is the really scary step. What's the rule for component orientation? Anyone? Anyone? Long and squared. That's it. Okay. So now these, of course, are going to go through from the front to the back so that you can see them, right? And now I'll give you another little tip here. Whenever you're actually building up a circuit board, I always recommend that you do not put the component all the way down against the board. So if I were building this for some other reason, okay, if this were an actual circuit that was going to be used somewhere, I would leave about 1/4 of an inch of lead sticking through, see, like that, right, instead of like this. In this particular case, because we want this to be really nice and strong and we want him to look like he has eyes, you go ahead and pull it all the way down. But the reason for leaving that extra little lead length is twofold. Number one, it keeps the heat from going up the lead and into the component because you have a little bit more length of lead, right? That's number one. Number two, irrespective of how carefully you follow the long straight rule, you will, from time to time, get a component in there backwards, right? If you get a component in there backwards, the best way to remove the component is just clip the leads off, and now you have a little bit of lead left so you can turn it around and put it back in the right way, okay? So when you're just building stuff at home and building kits, and if you go on with electronics, always leave a little bit of lead length. In this case, go ahead and push it all the way down, make sure you have the long lead in the square hole, turn the thing over and sit him on his face, and solder from the back.
Are we going to do both?
Yes, but one at a time.
One at a time.
And again, solder one of the leads of the first LED. Stop, turn it around, look at where it is, and make sure that it's flat and that it's where you want it to be, and then go back and solder the other lead. The other reason for doing that is because it gives you a little bit of a pause between the two leads and cuts down on the total amount of heat that the component has absorbed, thereby hopefully keeping you from burning it up. This is the one where if something's going to go wrong during this exercise, it's probably now. Don't be tentative, push down hard. The board will want to whack to one side. That's normal. You can put both LEDs in if you want it to be a little bit more stable. That helps sometimes. The lead bending. Very good. So we have a crooked man here who bends the leads.
Not a good idea.
No, it's actually a great idea. It's a good idea. So what you can bend the leads, you can put the thing through and then bend the leads off to the side a little bit, and it'll hold the component in place a little bit better.
And that LED should be very firm. It won't wobble at all if it's properly done. Is that right?
Yes. If it's wobbling, then you probably have a cold solder joint, which I would love to show everyone.
Okay.
Actually, that's just a completely cold solder joint, so yeah, there's no solder joint.
Okay.
So you may need to clean your tip a little bit, and then make sure that you're pushing it right into the corner at about that angle, so that you're getting it in there, and then hit with the solder on the other side.
Yeah, I get one looks funny. So I wonder if it's a cold joint.
That's a joint that has a lot of potential for being cold. It looks good, but yeah, that's the kind of a one that you want. Can I just show that to everybody really quick? Sure. Take a look at this joint on the left-hand side there. Look really close at it. Can you see how it looks kind of dull and not smooth and not shiny? The one on the right looks all nice and shiny and everything. That's the kind of a joint that might be a cold solder joint. Okay? You want it to be just really good and shiny. So I'll go ahead and pull that up for anybody that see it. You see the difference there?
Oh, yeah.
So thank you very much for the opportunity to show everybody that. So you can see how it's kind of, yeah, exactly. Did you see that?
And how do you fix it?
Hit it again with the iron. The solder is going to flow down and fill in the gap between the two. If you still have too much solder and you do that whack method, please let everybody know before you do it because it scares the heck out of your neighbors. Okay, everybody got at least one LED in? Go ahead and do the next one. Again, making sure that you put the long lead in the square hole. Spread them out a little bit. You want enough solder to flow in and fill the whole area around the pad. Oh. What you don't want to learn how to do this stuff? I'm listening. Okay, all right. Oh, that's fun. That's fine. I'm just giving myself. Anybody having any trouble other than with the stand, which is incredibly annoying? So now the question is, once they're all soldered in there, how do we get rid of those long leads? Some brilliant individual has brought the little snips. These are absolutely wonderful. Bias cutters, or I can't remember what they're exactly called, to be honest with you. But they're a particular type of cutter that has that little bit of an angle at the side, and so it's just perfect for getting in there and snipping off leads. The other way to do that, which is what we typically tell people to do, is once you have them all soldered down and everything looks good, just take the leads and start bending them back and forth, and you do that 2 or 3 times, and they'll crack right off. The extra lead. I mean, don't bend the LED back and forth, bend the extra lead. Okay. And now we're on to the race part. Who's the first person who can pop in their battery? Making note of the polarity of the battery. The plus side, the side that's marked plus on the battery, goes against the printed circuit board. The negative part is against the holder. And hopefully when you do it,
It says positive up.
it does. Wait. I think I lied.
Oh, okay. No, okay, but positive is the big side.
Oh, I'm sorry. Okay. So the part of the battery that's got the bump on it is the negative side, and that goes against the printed circuit board, and the positive side is the outer case, which goes against the holder. Wow. Don't listen to me. Just read whatever the instructions say. Hey, look at that. We got a winner. Woo, woo. Googly eyes. Oh, wait, but you have
Which way is up, which way is down? I cheated that one.
Positive is up. That's marked on the battery.
That's great. There we go. Okay, now hopefully somebody puts it in there and it doesn't work. Because what we want to do is we want to have it go in there and have somebody's not work so then we can troubleshoot and diagnose. Okay? If everybody's works, then I just don't know what we'll do. It'll be horrible. Somebody's has to not work. What's that? Oh, yeah, just go ahead and solder that again. I've never seen that before. That's unique. Okay. I'm seeing googly eyes everywhere. It's just horrible. All right. So that leaves me with nothing to do but just go through the.
No, wait a minute, I don't have any
Troubleshooting.
lighting up.
What's going on? Oh, we have one that's not lighting up. Okay, good. Let's see what's going on.
One of them looks really dull. It's really short.
Yeah.
They're dull, but they are.
Okay,
Okay.
okay.
You got the battery backwards. It was very confusing, so I totally understand that. And the problem here is that getting these batteries back out again.
Yeah.
Try to push battery in that way.
That way. And it doesn't matter the rest of the way.
Oh, that's
Is there
interesting.
an orientation to it at all?
No, it just has to be in there.
There's on the battery, there's a plus sign. You can look on the battery.
She meant around.
Oh, yeah.
That's really interesting. You know what I think is happening with this one? I think the battery's dead. let's test that theory, okay? So how do we test that theory? We swap out components, right? We'll come out of there and save some energy. Let me see if I have another battery really
I
quick.
think it's the LED.
Oh, the LEDs on
That
that.
you turn, as you turn it off and on, it separates through because I think I've seen this at Radio Shack.
Here, try
This
this.
one is the Radio Shack.
Try this battery.
Yeah.
You had it the same orientation, because you had the orientation right.
Yeah, it's hard to.
You know what you have is just voltage.
Right.
And they just probably underneath this is where you have the line going up through that around
Exactly.
finishing.
So these LEDs are a little bit special. They're not your standard LED. They actually have a little chip somewhere behind in there that's making it do the little googly thing. So did that light up then or no? No, still not?
Hers is also not lit up.
Really? Well, I thought it was working, but no? Okay.
Got a piece of lead not be
All right, let's
high
see
enough.
what's going on. No, I don't think so. I think it's fine.
Where those we'll put this
Oh, look at that.
Oh, cool. Oh, they're just working on it.
Okay, so what's happening is that there's some kind of a problem with the connection. This is really interesting. I love this kind of stuff. Okay, so let's pop that battery back out of there to see what the problem is. So one of the things I really like to highlight in these talks, whenever I do them, is that electronics in general is an absolute nightmare. All kinds of things go wrong. Things just go wrong and go wrong and go wrong and go wrong, and it's just frustrating as all heck. But that just adds to the joy when you get to the end and you actually get the stupid thing to work. Or at least that's my philosophy on it. So what I always tell people is, whenever you start doing this stuff, you build the kit. One of the reasons why I try to do these classes is because people just buy these kits and they try to build them and then they don't work, and then people get all frustrated and upset and everything. Okay, so here's what I think is happening. I think that is up too high. And I think what needs to happen is that we need to melt and push that down to change the angle of the thing so that it's flat again. So the way we're going to try to do that is by setting it right here, and then the line up this one. And yeah, it would be dangerous to do that
Don't
with
do
a
it
battery.
with the battery.
Yeah, but it's like really close. There's something not right here. Or was that, did I put the half-dead battery in there maybe? Okay. Time to get out the tools. So sometimes you just have to mess with stuff and play with it, and eventually you get it to work. Has anybody here done any, there we go. See how nice and bright that was? It's still just,
It's just a contact. There it goes. That's super bright now.
that is just weird.
What did you change?
All I'm doing is pushing on it.
That might be a cold solder.
Well, yeah, but I just redid that solder joint.
Oh.
Couldn't be a cold solder joint if I did it.
Is it the battery?
It's the surface contact with the circle.
Yeah, that's what I'm thinking.
There needs the current, the way the colors are changing because it's current dropping from current for certain colors. You probably can't get there.
I thought you were a beginner.
I'm bad at soldering, but I'm a very good engineer.
Electrical?
Yeah, electrical engineer.
Oh, this is good. This is like the shame of being an electrical engineer who doesn't solder well. I'm glad that you've come to us
It's
today.
like an AA.
If it makes you feel any better, I'm a mechanical engineer who doesn't work on my car.
Yeah.
Not working with cars.
So here's what we're gonna do. This
It's
is gonna be really
for
fun.
big companies, you know.
I'm gonna
you
use
get
my
people,
nail
you know,
because
special
it doesn't hurt so much. It's not my skin, right? That's why I have long fingernails. I'm gonna pull on it. Touch this.
Assistant engineer.
They don't actually teach you this sort of stuff in school.
You know, there's a real problem in America today with there not being enough making going on and enough hands-on stuff. I'm gonna do a little thump here. Okay, so I just want to go in there. That looks like an absolutely lovely lump of solder there. Don't think that was it. The only other thing I can think is that there's
Thank you,
something
sir.
wrong with this particular thing circuit board. I'm gonna try putting this into this board. And we'll see if we can change it as well. But it may just be that you got a defective tip. That does happen.
Did you give out your Wi-Fi access?
Little. Do something really dumb here. Hold it with my finger while I touch it. Well, I'm just I've done so much of it that I kind of have lost respect for the iron. It's like those people who, you know, they like handle, you know, crazy snakes or spiders or something like that, and they just don't care anymore. It's not that it doesn't hurt when